So let's move to the next question. Question number 8. Question number 8 is using theorem 6.2, prove that the line joining the midpoints of any two sides of triangle is parallel to third side. This is actually the midpoint theorem. What it is saying? It is saying line joining the midpoints of two sides. We have a triangle PQR, and here A and here B are midpoints of PQ and PR. Then we have to show कि AB is parallel QR. Okay. Here it is given that A and B are the midpoints of PQ and PR respectively, and we have to show that AB is parallel QR. But we have already proved it in class 9th. Okay.
Yes.
But there we proved it by constructing or making this as a parallelogram. Means here we have to prove it using theorem 6.2. Okay, we have to prove it by using theorem 6.2. That is the converse of BPT, not by the way that by we proved it in class 9th. We have. So let's see, beta. This one is going to be very easy, I think. Here PQR is triangle in which A and B are midpoints of PQ and PR respectively. Okay. PQR is a triangle. A and B are midpoints of PQ and PR. Okay. And we have to show you have to write these things. Okay, when you are going to prove this theorem like this, you have to write these things. Okay, we have to show AB parallel QR. Now once again you have to think about the theorems that you have studied in this chapter. You will note that here we have to prove that this is parallel to this, and if you prove AP upon AQ is equals to BP upon BR, then by converse of BPT, AB will be parallel to QR. So we will focus on that, how we can show that. Okay. So here it is given that A is the midpoint of PQ.
Yes.
And we will take the help of the given things only, na?
Yes.
So A is the midpoint of PQ and B is the midpoint of PR. So what you deduce A is the midpoint of AB. You can deduce AP is equals to AQ. Means AP upon AQ is equals to 1. AP upon AQ is equals to 1. Reason? A is midpoint of PQ. Okay. So AP and AQ are equal, then they are equals to 1. Make it equation 1 first. Now again BP upon BR is also equals to 1. Reason is same. B is midpoint of PR. B is midpoint of PR. Make equation second. From first and second, what you can write? From first and second, you can write कि AP upon AQ is equals to BP upon BR. Okay. AP upon AQ is equals to BP upon BR. This implies that AB is parallel QR, right? By converse of BPT. Okay, beta? Yes. Now this is proved. Yes. What you are saying?
डायरेक्ट बीपीटी स्टार्ट करना चला जाता है।
हाँ।
सर बीपीटी डायरेक्ट लगाए तो पीए पैरेलल टू पीए अपॉन एक्यू इज इक्वल्स टू पीडी अपॉन बीआर रहता।
But how PA upon AQ is equals to BP upon BR? How you can write it? So BPT theorem is applies only there when this line is parallel to this, na? Here we have to prove that this line is parallel to this. Okay.
Yes.
So let's move to the next question. That is question number 9. Okay.
Yes.
In question number 9, it is given that the ABCD is a trapezium in which AB is parallel DC and its diagonal intersect each other at the point O, so that AO upon BO. So we have, first of all, we have to draw a trapezium here in which AB must be parallel to DC. So here we are going to draw a trapezium. A, B, C, D, and it is given that AB is parallel CD, and it is also given that their diagonals are intersecting each other at point O. Means and they are intersecting at this point O. Okay, and we have to prove कि AO upon BO is equals to DO. तो बेटा देखो, directly when you think about कि how you can say AO upon BO is equals to CO upon DO, you will not get success in solving this question. you have to draw a line that is passing from O and parallel to AB. Here we have to make some construction. Draw OT, okay, parallel AB, OT. Look at this, okay. OT. This is the parallel AB, okay. And if this is the parallel AB, this will automatically will be parallel to CD. Okay. This will be automatically parallel to the CD. So we have make a construction. We have draw OT parallel AB parallel CD. Now in triangle ADB, in triangle ADB, look at AT upon DT. AT upon DT is equals to BO upon OD, है ना? BO upon OD by BPT. Make it equation 1. Now in triangle ADC, in triangle
ABC.
No, ADC. Because when you take triangle ADC, you will get OT parallel CD, and you will apply BPT, you will get AT upon DT equals to AO upon OC. In triangle ADC, yes, AT upon DT is equals to AO upon OC, right? By BPT. By first make it equation second, and by first and second you can write AT upon DT. AT upon DT is equals to BO upon OD and AO upon OC. So from first and second, you can write BO upon OD is equals to AO upon OC. CO or OC, okay? You can write both. Okay, I am writing it CO, okay? Instead of OC, I will write CO. AO upon CO. Now we have to prove AO upon BO is equals to by simply transposing it, yes, you can get BO upon AO is equals to OD upon CO. We have to prove CO upon BO, right?
Yes.
1 minute. AO upon BO. Now transpose these two things only, okay?
Sir, cross multiply करने को BO into CO is equal to
CO upon OD is equals to
AO
upon BO. Okay? By transposing means interchanging these two things.
sir इसको cross multiply करके भी कर सकते हैं.
In cross multiply, we multiply this by this and this by this also. But we have but here we have only transposed CO to this side and BO to this side. We don't have to write.
Both are right.
We don't have to write what we have done. By writing this, put this sign implies that and write this one. Okay? Hence proved. Hence proved. Actually here it has written ki DO. DO and OD are same things. Okay? Okay. So let's move to the question number 10. The diagonal of quadrilateral A, B, C, D intersect each other at points O such that AO upon BO is equal to CO upon DO, so that A, B, C, D is a trapezium. It is the just opposite of the last question. Here it has given what we have proved in last question. It is already given here. It is given that ABCD is a trapezium. A, B, C, D is trapezium. No, it is not given that it is a trapezium. It has given it is a quadrilateral. Okay, we are not taking it as trapezium. We are taking it as only a quadrilateral. ABCD is a quadrilateral. The diagonals of quadrilateral ABCD intersect at O. So we will construct diagonals. Okay, the diagonals are intersecting at O, and given is AO upon BO is equals to CO upon DO. Okay?
So it is required to prove.
No, it is a given, na? We have to show that ABCD is trapezium. And to show that ABCD is trapezium, we just have to prove that its two of opposite sides are parallel. We will show that this side is parallel to this. So we have to think about how we can show that AB is parallel CD. So okay, this one is the given. Now you can also write it like this. AO upon CO is equals to BO upon DO. Okay. Now join. We have to make some. You will get this point just after. When I will write here, you will get your point why we have changed. Now, join no, not join, and draw. draw OT. We have draw OT.
This is required to prove.
We have draw OT. Okay. Now it is given that AO upon BO, AO upon OC. Sorry, here I have changed it in like this. No? AO upon OC is equals BO upon DO. Now draw OT parallel AB. Okay, draw OT parallel AB. So it will no. It will only parallel to OT parallel. OT parallel AB, or you can also draw OT parallel CD. Both are the in both condition you will get same thing. So here it is given that we have draw OT parallel AB. So by this you can write AT upon DT, AT upon DT. What?
In which triangle?
In triangle ABD. ABD. Okay. AT upon DT is equals to BO upon DO. Right? Okay.
Yes.
AT upon DT is equals to BO upon DO. Okay. But BO upon DO is also BO upon also equals to AO upon CO. So from first and second, by BPT beta, by BPT. From first and second we can write कि AT upon DT, AT upon
DT is equals to AO upon CO.
yes, AO upon CO, and this implies कि OT parallel DC, right? This implies OT parallel CD also by converse of BPT.
So AB parallel to CD.
Here OT is parallel CD as well as OT is parallel AB, है ना? So we can say कि AB is parallel CD. Now look at in this. What we will write कि here OT parallel AB by construction, construction and OT is parallel CD. Proved. So we can imply that AB parallel CD. Okay. Hence quadrilateral AB CD is trapezium. If two sides are one pair of opposite sides are parallel, then it is trapezium, right? Okay. So in next class we will discuss exercise 6.3.